Greetings folks and welcome to the Electromaker Show. This is your roundup of all things maker and embedded and lovely. And perhaps unsurprisingly, this week's show is dominated by the Raspberry Pi Pico 2 and the accompanying RP2350 chip that powers it. Although we will also be stopping off briefly to talk about the Particle Tachyon, a 5G AI-ready single-board computer that has gone live on Kickstarter and has already absolutely smashed its goals. And in fact, this is quite an interesting show for me because in my mind, Raspberry Pi are the single-board computer people, yet with the RP2350 they're doing something quite revolutionary with microcontrollers, whereas on the other side of things I'm used to Particle making microcontroller based IoT devices, and they have been doing so for the last decade or more, and they come out with one of the most revolutionary SBCs, and I'll get into that when I get to it. So with all of those things, including a whole bunch of new RP2350 powered development boards to get your teeth into that we'll be talking about today, let's get on with the show. Now, this show is going to be very heavily based around the Raspberry Pi Pico 2 and the RP2350 because the release of both is really quite exciting, and we'll be getting into some specifics about the chip, some specifics about the board, and later in the show also a lot of different partner boards that have already been behind the scenes working on getting them out, from robot controllers to industrial controllers to Ethernet controllers to retro gaming. There's a huge amount of them. But to begin, I'm sure many of you will want to know the real cliff notes, the real differences that matter when it comes to these boards. So let's start with price. One of the wonderful things about the Raspberry Pi Pico is that it was just $4, and the Raspberry Pi Pico 2 follows on with that trend, because it's a massive upgrade, and we'll get on to the reasons why it is a massive upgrade in a moment, but it costs now only $5. And one other thing that I think people will probably be very interested in finding out is how pin-to-pin compatible the two chips are. Now, the RP2040 chip and the RP2350 chip are not pin compatible at all in any way, but the Raspberry Pi Pico and the Pico 2 are. Now, the castellated edges on this chip make it fantastic for actually embedding into a PCB, and while you are prototyping, that's maybe something that you will want to do, given that the Pico boards have everything you need on them to program them, and then if you design a custom PCB with extra peripherals and sensors and things on it, you can just put the footprint of the castellated edges down and plop it down and use it as is. So if you are already doing that in any of your designs, the Pico 2 will be a drop-in replacement, and as far as I understand, the SDK has been designed so the code can be drop-in replacement as well, provided you are using the ARM cores of the chip. And this is the first really interesting thing about the Raspberry Pi Pico 2. So we'll come back to some of these details later, but in brief, the ARM Cortex M0 Plus of the RP2040 has been upgraded to an ARM Cortex M33, running at 150 MHz instead of the 133 MHz that the RP2040 ran at. However, the RP2350 also includes two Hazard 3 RISC-V cores, which can be used separately. This isn't a quad-core microcontroller. You can have two ARM Cortex M33 cores, which by the way have the ARM Trust Zone involved. Again, we'll come back to that later because you can win $10,000 if you manage to crack that Trust Zone core. Raspberry Pi have teamed up with Hextree for an amazing Capture the Flag challenge. But yes, it includes two RISC-V Hazard 3 cores in it, which is really interesting because right off the bat you have industry standard cores with security that allows the RP2350 to be used in places the RP2040 never could have, but also experimental RISC-V cores that allow people who want to be right on the very edge of things and make things using RISC-V in the chip as well. And as far as I understand it, provided that you're not actually using any inline assembly in your code, the code for ARM and RISC-V is identical. You can switch over your entire code base to the RISC-V cores just by changing a few flags in the boot. Again, I will in a moment go through things in a little more detail, but I think in terms of other things that you might want to know right now, you get twice as much on-chip SRAM with the 2350. You also get another block of state machines. Previously, you had 8 PIO outputs, which was 2 blocks of 4. The programmable input outputs of the RP2040 were by far the most interesting part of them. Tiny little state machines with their own logic that could do things at incredibly high speeds, and you could turn them into pretty much anything. You could do such precise timing on them that you could turn it into a driver for almost any kind of peripheral. You now have another block of those state machines, so you now have 12 in total. Other upgrades include single precision floating point calculations thanks to the onboard FPU and some DSP instructions on the ARM Cortex M33 cores, but given the fact that the source code between the two cores is supposed to be completely cross-compatible, I would imagine that those things are reflected on the RISC-V Hazard 3 cores as well. However, I think a really big thing for a lot of people will be the changes changes to power consumption. This is the blog of Jeff Geerling, yes, the same guy with the massive Raspberry Pi YouTube channel, and his video on the Raspberry Pi Pico 2, by the way, is fantastic. I'm going to link this blog post in the description of our video because it embeds the video he made on it as well. But his tests on the power usage of the Pi Pico 2 were interesting. They were only partially successful. He says basically he's still a noob at C, so he couldn't get the Hello Sleep code ported to the Pico 2 in time, and the MicroPython build seemed to flake out with messing with sleep states. In fact, the RP2040 and sleep and deep sleep was something that I think a few people had headaches with. I've read a few posts with people talking about it not having quite as lower power consumption as they would expect in deep sleep, others talking about having difficulty waking it up from deep sleep to do certain things. And apparently the RP2350 has covered this, but we're just going to have to take their word for it for now. However, the datasheet does mention that the low power sleep states can go down to as low as 10 microamps, although Jeff mentioned in the very next sentence the first thing I thought, which is like, what does that actually mean? Realistically, his guess is that it'll be somewhere between 10 and 100 microamps, but it should be a lot better than the original RP2040. And it says, again here, looking at the SDK, it seems like it won't take as much effort to get it into a dormant state and to wake it back up. So I have begun to make an Excel spreadsheet comparing the RP2040 and the RP2350. This is by no means finished. All I've done so far is put in a few of the larger things that seemed like differences between the two. So where I didn't notice an immediate difference, I haven't put it in yet, but this is not a finished thing by any means. I just was somewhat inspired by Andreas Spiess's wonderful ESP32 spreadsheet that covers pretty much every single variant of the ESP32 you could imagine. But yes, the RP2040, as I previously mentioned, CPU and CPU speed are different. The SRAM is different. One other thing, that you get more channels of PWM on the 2350. You get 24 output channels of PWM on the standard chip. And the standard chip is important because when I say the RP2350, that is the standard chip, and it comes in a couple of different sizes. So the RP2350A has 30 GPIOs and is a 7x7 QFN60, and that is the one that I believe you find on the Pico 2, whereas the B variant has 48 GPIOs, which is a 10x10, an 80-pin chip, the 10x10 footprint. So you actually get another 18 GPIOs if you go up a size on the form factor of the chip itself. And when it first released, that was it. There was no other mention of other chips, but very shortly after the fact, they mentioned that the RP2354 would be out, which has 30 GPIO, is the same as that, but comes with 2 megabytes of stacked flash inside the chip, giving you a total of 6 megabytes rather than the 4, I think. And again, there's a variant for the 10x10 QFN80 as well. So if you're working on something that requires onboard flash space and you need just that little bit more, it seems like Raspberry Pi are going to be putting out a few different variants of this chip. And you can understand why, really, because again, the security is what makes this chip very different. The fact that the ARM trust zone exists on the Cortex M33 side of things means that this is something that could find its way into much more professional grade hardware that previously wasn't able to use it because it required on that trust zone for security. Now that it's there, I can see the RP2350 being used in a massive variety of projects. And the ARM trust zone is something that I am not familiar with. I've never really had to mess with the security side of things, but just having a quick look into it, it seems like the things that the RP2350 have are all things that come courtesy of the trust zone that you can implement into your own chip designs, like signed boot support, 8 kilobytes of on-chip anti-fuse one-time programmable memory that is something that you program once and it can never be touched again once the chip goes out of the door, SHA-256 acceleration, and a true hardware random number generator. One other thing I didn't mention is that you now get up to 8 analog to digital converters, although I do believe that is only in the larger package size of the chip. The 10x10, as I mentioned back here, the 10x10 QFN80, I believe that's the only one that has the extended ADC on it if you did need up to 8 ADC channels. Once again, I've jumped to yet another overview of the RP2350, this time on the fantastic CNX Software, which gives you a plethora of information. I think this is all of the information that is available right now. I think they've been updating this article since it first appeared, and it also talks about the newer variants. Raspberry Pi have mentioned why it's called the RP2350. It uses the same naming convention as the RP2040, which is RP for Raspberry Pi, 2 for the number of cores, 3 for the type of cores, so it was 2.0 for the ARM Cortex M0, this is 2.3 for the ARM Cortex M33. 5 and 0 are their interesting way of talking about how much RAM and how much flash something has. Sorry, not flash, non-volatile storage capacity. So log2, which is log2 multiplied by the RAM divided by 16 kilobytes, and that gives you 5. It's a naming convention. It's a name. The CNX Software article also usefully outlines how it can work with the ARM cores and the RISC-V cores, and the way precedence is set in terms of which of these cores is used. So there are various flags that can be set. And so if you set the ARM flag to disabled, then only the RISC-V cores can be used. And again, if you set the RISC-V cores to disabled, only the ARM cores is used. If you want secure boot, so if you want the security functions involved in the trust zone, which is an ARM product, you can only have the ARM cores. And then if you set the critical boot architecture, then both are permitted, but the default is RISC-V. And if you set none of the flags, then you will just get ARM. For most people, this is probably something that you won't mess with all that often, but it is worth knowing. I did come across this actually in the documentation for the Raspberry Pi 2340, but when it comes to filming, I've already closed that tab, and I had the CNX Software article open anyway. But this is something that is documented, and you will be able to switch between those different chips. I can see this being a really interesting thing just for people who want to see if there's any difference between the two chips, because again, the code, provided it's all C code and has no assembly, is part for part. So you can literally just change one of those flags and then observe if you have any differences with your runtime, with your debugging, with the RISC-V chip compared to the ARM Cortex M33. Finally, we've already mentioned the Pico 2's price is $5. There's a few other things as well. The RP2350A, which is the one that you find on the board, will be 10 cents more expensive than the RP2040, costing 80 cents in 3,400 unit reels, or $1.10 in single unit quantities. The RP23B will cost 10 cents more than that, so 20 cents more than the RP2040, and the RP2354 variants with 2 megabytes of flash will cost just 20 cents more than the flashless versions. So there's a few different variants of it, which is an interesting choice, I feel like, because one of the main things about the Pi Pico and the RP2040 that bothered people is that it did not have any onboard flash. You always had to have an SPI chip attached to it, and of course that is the case with this as well. I realize now that one of the things I said here made no sense whatsoever, that the 2 megabytes of stacked flash you get with the RP2354A and B will add to the flash that you get with the RP2040 and the RP2350, which of course makes no sense, because the RP2340 and its follow-up, the RP2350, both rely on external flash for storage. You need a QSPI flash chip up to 16 megabytes, which is quite nice. That's quite a large amount of program flash, but it does need to be an external part, which adds to your bill of materials. Now, of course, if you want to avoid that and you only need 2 megabytes of stacked flash, the RP2354 is going to be for you, because it will cut down on your bill of materials. And of course, I imagine in future they will come up with versions with more and more stacked flash on the die for various different uses. Now, I mentioned that security is something that Raspberry Pi was taking very seriously with the RP2350, incorporating the ARM trust zone into the design of the chip. And this is something that they are taking seriously enough to put their money where their mouth is. This Hackaday article by Lewin Day briefly goes over the Capture the Flag challenge that the Raspberry Pi Foundation have put together with hextree.io to give $10,000 to anyone who manages to hack the security features of the Raspberry Pi Pico 2. And sorry, the RP2350, by proxy, the Raspberry Pi Pico 2. Now, this was something that was actually went through at DEF CON this year. People tried to hack into the chip at DEF CON and failed. And if the people at DEF CON have failed, that's already quite it's already quite a secure thing that they have done there. But if you are interested in finding out more about this, I'm going to leave a link to the Hackaday article in the description of this video, just because the very first link out of it goes to the GitHub page for the hacking challenge, which has the full README for how you can do it. There's also a quick explainer which takes you out to the hextree page about it as well. And in short, they have hidden a word in one of the one-time programmable rows. So the OTP rows are things that get programmed once, and then you can never program them again. Now, Raspberry Pi have made it so you will be able to program them again, but you would have to overwrite what is already there. So you can't win the prize by using the tools that they've given you to get that functionality back from the chip. I just wanted to make that very clear, that Raspberry Pi haven't completely destroyed the OTP by starting this challenge. No, the idea is you need to break it in order to get the 128-bit word out of the OTP and then give it to them in order to claim the prize. But yes, if you are a hardware hacker and you're interested in trying to win $10,000 and of course all of the clout that comes from being the first to break the security of the RP2350, head to the link in the description, head to the GitHub page to find out all the instructions. You have until the 7th of September 2024, 4 p.m. UK time. Now, later in today's show, we'll look at a few of the new development boards featuring the RP2350. But just for now, as a self-taught engineer who spends a lot more time talking about microcontrollers than actually playing with them or programming them, I've never released a product. So my opinion on the RP2350 isn't really worth much. But for what it's worth, I think Raspberry Pi have done something really quite clever here, because they could have catered just to the industry by making this an industry standard chip with security on board that allowed it to be used in designs that usually would not allow for the kind of chip that the RP2040 was. On the other hand, they could have made this a purely maker-focused, really open, really easy to program platform that did not think at all about things like security and just leverage what the RP2350 can do purely for fun and for hobbyists and for people who want to make things that don't require a high level of security. But instead, they've done both, which I think is a really interesting touch. They didn't make the RP2350 pin for pin replaceable with the RP2040 because that would actually be throttling what the RP2350 can do. So instead, they made the Raspberry Pi Pico 2 pin compatible with the Raspberry Pi Pico 1, and they both have castellated edges, meaning that they can fit into PCB designs. So if you are someone who is right up at the point where you're designing your own circuit boards and you're basically making fully fledged products but for yourself, not necessarily for public release, or you're running a boutique shop where you make products that are designed to be sold to the end user but without any kind of agreement or any security protocols in mind, you can just pin for pin swap out the Pico with the Pico 2 and then actually start incorporating that security into your designs if you want to. Alternatively, if you're someone working in the industry, you now have a chip which presumably will have a bunch of different variants coming out. You already have the versions with some onboard flash. I can imagine they'll put out a few different variants as well, which are ARM Cortex M33, have the trust zone involved. And that trust zone is something that powers a huge amount of the industry already. It is a trusted zone. See, now that is a good name. It's something that is trusted throughout the industry already. However, they've included those two Hazard 3 RISC-V cores as well, which work with the same program code provided that you're not using assembly. That said, if you did want to use assembly, if you set the flag to make it a RISC-V core, you can use this chip as another way of learning RISC-V assembly if that's something you're interested in doing. But if not, and you want to stick in C land and C++ land, the Pico SDK makes it very clear that code works on both cores. All you have to do is change the boot flags. So if you're looking for an experimental microcontroller that has RISC-V to learn the exact ins and outs of it and see if it's something that you would want to use in a design of yours in the future, then the Raspberry Pi Pico 2 is the perfect spot for that as well. It seems like they've come up with something which really should appeal to absolutely everybody and managed to keep the price point down to an incredible $5 for the in-house development board. And that is by far not your only option. There are many other third-party development boards that have come out with a plethora of wonderful ideas attached to them, and we'll get on to those a little bit later in the show. But yes, my first impressions of the Pico 2 and the RP2350 line of microcontrollers is that it's been so very well thought out so that it caters to the widest possible group of people who are interested in programming microcontrollers, and for that I really am very happy with the way that they've done this. Just briefly before we move on, Electromaker is funded entirely by the Electromaker online store. We don't run any adverts on our YouTube channel and we don't have any sponsors on our podcast. We probably could do, but instead we have our online shop at electromaker.io/shop. There you will find things from people like Raspberry Pi and Arduino, also things from third-party vendors like Sparkfun, Adafruit and Pimoroni, along with things from Nordic Semiconductor, NXP, and many people who are considered sort of high up in the industry side of the embedded market. So whether you're looking to buy your first starter kit as a gift for someone else or yourself, or you're working in a company and you require 10,000 of something, the shop is definitely worth taking a look. If there's not something listed directly in the shop, it's also worth giving our shop a call. You will find a number listed right at the top of the shop page, and that will get you through to someone who will be able to help you if you have large or unusual orders. And that said, despite the fact that we do not monetize our YouTube videos, it would mean a lot to us if you could make sure that you are subscribed to the Electromaker YouTube channel. If you click a like like on this video, only if you like it, of course. That will help the YouTube algorithm stuff. And leaving a comment as well is nice, partially because that also helps with visibility, but it's very nice for me to know what you think of these shows. I am, after all, just one person making the show alone in his attic every single week, and I get a lot of very nice feedback about it, but I always like to hear what people like about the show, what they do not, what I could potentially do to improve it in the future. It is time for a quick funding website things. This week we'll be stopping off at Kickstarter because while the front and end of this show are about the Raspberry Pi RP2350, a microcontroller that is revolutionary from the single board computer company that is Raspberry Pi, Particle, who I think of as the microcontroller-based IoT company, have put out one of the most interesting single board computer designs I have seen in some time. So, the Particle Tachyon is a 5G single board computer. It has 5G connectivity along with Wi-Fi and Bluetooth out of the box. It is also AI ready. It has an AI accelerator on board, and that is because the guts of this single board computer are more like a mobile phone or tablet than the usual single board computer that you would find. Now, this might ring alarm bells for some people. There are a plethora of single board computers out there that run Android, and they're not necessarily the easiest things to program and use, but this has upstream Linux support. So it's using the same hardware as a mobile phone, but it's designed to have a similar experience to a single board computer. And of course, off the back of that, you get the online presence of Particle, who have been for the last 10 years providing billions of different connections to different customers with their online hub for things like telemetry, for over-the-air programming, for data storage and capture, for everything that you would want an IoT device to do. By the way, this is Zach, who is the CEO of Particle, and I will be chatting to him later on today about the new Particle Tachyon board. We managed to, in quite short notice, sort out an interview, which can't fit into this show, unfortunately, but in just a couple of days' time, we're going to put out yet another Electromaker show, which will feature the interview from Zach about the Particle Tachyon, about Particle in general, where the company started, so you'll be able to find out a little bit more about it then. I just wanted to mention the Kickstarter right now because it is still ongoing. And of course, they've absolutely smashed their goal. They wanted $10,000 and they've got almost over $250,000 in support, and it's easy to see why. Now, I'll be leaving a link to this Kickstarter in the description, and I highly recommend coming and reading it because it sounds like a weird thing to say, but as someone whose previous career was as a writer, both a copywriter and an article and a news writer, the Kickstarter is written beautifully. It's really well written. It gives you all the information you need in the order that you would expect it. The very first thing that I thought when I saw this, despite being a fan of what Particle do and their fantastic track record, is why do I need another single board computer? And after answering the initial question what Tachyon is, they specifically answer this question. In short, the idea here is that this gives you a slightly different approach to how things work than a regular single board computer. It gives you a little bit more power, and of course it integrates everything that Particle has been doing for the last 10 years with their IoT service. And I know the word service has a bit of a dirty reputation because not all of these things necessarily work the way you expect it to, but as far as I am aware, Particle has had a pretty clean record for the last 10 years when it comes to providing their IoT service to its customers. Now, as I previously mentioned, this under the hood is a lot more like a mobile phone or a tablet than it is a traditional single board computer, but your user experience will be much the same. So if you are interested in the specs, they're here on the Kickstarter page. The cliff notes being it has an octa-core Qualcomm Cryo CPU, 5G connectivity and Wi-Fi 6, and the other thing that jumped out to me was the 12 TOPS AI accelerator, and then there are two versions of it, one with 8 gigs of RAM and 128 gigabytes of storage, and one with 4 gigabytes of RAM with 64 gigabytes of storage, which is of course all extendable via the USB 3 port. In fact, the only thing that I can see that might be a point of contention for some users is that it's following the trend that many computers are using now, in that it has two USB 3 Type-C ports, and if you want to get, say, Ethernet or HDMI out or anything like that, you attach a hub to that. Some people will find that shocking and horrible. As someone who grudgingly at first bought an M1 MacBook so I can do video editing on the road, I've quite quickly got used to that, and I'm no longer grumbling about a lack of USB ports anymore. I was certainly one of those people in the past, however. The animation here gives a nice overview to how connectivity works with the Tachyon, actually, because you have the USB hub here, and that's providing USB, and it's also providing HDMI, but there is a separate connector for battery, obviously, so you can power it separately. There's also a connector for Raspberry Pi compatible hats, and also two camera lanes here. As you can see, they're connecting Raspberry Pi cameras via ribbon connection there. The one other thing I want to briefly mention now, because it seems pointless, we're going to hear it from their CEO later today anyway, but that they have an online platform. Particle have had one for many years. And if you buy the Tachyon board, you get free access to it. And that free account allows you to have up to 100 devices. It even includes a plan for the onboard cellular connectivity, although the free plan for the cellular connectivity just gives you things like telemetry data and device management. If you want to do more with it, like shifting data, you will need to buy a plan from them. And again, we can go into this when we talk to Zach. Now, the early bird version of the Tachyon is $140. And I want to jump right ahead of everyone who's going to say, why would I ever get one of these when a Raspberry Pi is this much or an Orange Pi is this much? If I said to you that there was a smartphone that was as powerful as the smartphones that are of this price, that was completely hackable and allowed you to do IoT things with it, you'd be amazed, because that's less than a quarter of the price than most actually decent smartphones. This is a different kind of single board computer, and I'm actually amazed that it is as cheap as it is rather than the alternative. I don't know what the final price of it will be when it comes out of early access on Kickstarter, but I am very excited about getting my hands on one of these to try it. And yes, I fully understand that when it comes to single board computers, we're very used to the idea that the original price of the original Raspberry Pi is how much these things should cost, but that's simply not the case with the market in the world as it is now. I feel like $150 is incredibly decent, and I just realized I was probably in the way when I showed that. So here we go. The Super Early Bird Tachyon, the first 1,000 backers get a heavily discounted pricing and early delivery, and the estimated delivery for the Kickstarter backers is January 2025, although from everything that I see from Particle, this is something that they will, without any issues whatsoever, have together and ready to get out of the door. I feel like they're the kind of company that would have thought about this. Of course, I could be wrong, but this is a Kickstarter that I trust pretty implicitly. Now, I already mentioned several times through this section that I'll be chatting with Zach from Particle later today. I'm very excited about that, actually. And I will be putting that show out as soon as the interview is cut together and everything. So you'll be getting 2 Electromaker shows in close succession with each other this week. I hope that's okay with everybody. But this is exciting to me because it feels like with single board computers, there's been a very similar idea behind them for quite some time, and with good reason. Raspberry Pi really knocked it out of the park with their original design, and there's a reason why that Raspberry Pi footprint has become so iconic and has been copied by absolutely everybody. And the fact that the standard thing for single board computers is the Raspberry Pi 40-pin connector for hats. However, this is something a little bit interesting because there's been a bit of a fork in the road since then. RISC-V is incredibly popular, and there's a good reason for it. And there are a number of RISC-V single-board computers out there now, but Android-compatible single-board computers that use the same parts as Android phones and tablets are few and far between, not that well documented, and cost a hell of a lot. If you want to get an Android development kit, you're going to be looking at a very high cost margin. This is something completely different. It uses that technology, but in a way that is very similar to the original idea of how single-board computers works, and it's coming from a company with a really good track record for IoT and using that service as a way of helping their customers. So I'll be very interested to hear from Zach about that, and we'll be putting that show out as soon as possible. And as always, I'm very interested to hear what you think about this. Will you be getting your hands on a Particle Tachyon? Are you going to wait until I speak to Zach before you make your mind up? I'd really love to know in the description. Not in the description, that's where I write. In the comments below. So the first half of this show was talking about the new Raspberry Pi Pico 2 and the RP2350. The latter part of this show will be briefly looking at a few of the third-party boards that people have been working on secretly behind the scenes before the launch of the board so that they'd all be ready to release more or less at the time of the board coming out. Now, some of these aren't actually released. Some of these are announced, but it means that they've had the chip and they've been working on it for long enough to have a product that they're willing to say, hey, this is going to be ready soon. We're just getting it ready for launch. And there's a few of them that are just kind of basic upgrades on the Pi Pico. We'll look at a couple of those, some of them which are very familiar small postage stamp sized little boards like the Zhao versions, and there's a Pico, a Micro Pico I think it's called, that we'll look at as well. And some of them are really more interesting. WizNet have put out an Ethernet version, which is very interesting to me given that just last week we were talking about their venture with Raspberry Pi to put out their combined Ethernet controller and RP2040 chip, which of course we can pretty much be sure that they'll be putting out an RP2350 version of that too. And there's also some industrial and even retro gaming uses for the RP2350. So let's dive right in. So I will be taking a few choice cuts from this powered by Raspberry Pi product catalog. This is specifically things that use the new RP2350 chip. Some of them are upgrades to products that already use the RP2040. Some of them are completely new products based around the new chip. And if you'd like to go through this in complete and exhaustive detail, I will link this in the description and you can go through the very, very many new boards that have come out. I'll sort of be picking one of each from each different category, like just general development boards, maker focused, things designed for PCBs, industry, all of that kind of stuff. But if you would like to go through it yourself, it will be linked in the description. So first, briefly, the familiar form factor of the Adafruit Feather RP2350, and this is the Adafruit Feather form factor. It will work with all Feather wings, which are the name of Adafruit's shields, if you're not familiar with Adafruit's products. And like all of the Adafruit Feather boards, it comes with onboard battery management. With this JST connector, you can plug a battery into it, which takes care of all of the charging and discharging, basically making this perfect for embedding into something. Another nice touch here is that you get a lot more flash here as well. You get 8 megabytes of flash, because as mentioned earlier in this episode, the RP2350 does not come with any onboard flash. It has to be paired with a QSPI flash chip, and they've decided to give a very generous 8 megabytes of it. 22-pin HSTX output port, Stemmer QT, which is their solderless plug-in device for using different modules and things via I2C without having to do any soldering or breadboarding whatsoever, and an optional PS RAM spot as well. There is also a Seed Studio Zhao variant of the RP2350 board. However, you're probably beginning to notice somewhat of a pattern here. The Adafruit board was not available, and neither is this. Whether that is because the initial runs sold out immediately, or whether they're still actually working up to release is another matter. I would imagine that they've had a lot less time to work on their third-party development boards than Raspberry Pi had to work on the Pico 2 in-house, which is probably going to be a similar story for most of the development boards we look at now, but it is nice just to kind of take note. So the Seed Studio Zhao is in the same form factor you would imagine, but it features the RP2350 chip, this time with 2 megabytes of flash space, so a little bit less, but most people like to use these in environments where they want a small form factor board to do small-ish tasks. And this one actually breaks out 19 pins, which is more than you have on the castellated edges. So if you do actually want more pins, you can see the solder pads here are for digital pins 11 through 15 you can find on the back here. Though the eagle-eyed of you would have also noticed you have battery pads here. This is another board that includes battery management out of the gate. All you need to do is attach a battery to the 2 battery points here, and it has battery management on board for you. 2 other boards of similar form factors are the Tiny 2350 by Pimoroni, which is another very, very small form factor board, and the Sparkfun Pro Micro, which is similar to the Adafruit Feather in that this is Sparkfun's own Pro Micro form factor, but with the RP2350 on board as well. And they're fairly similar to the other 2 we've just looked at, so if you're interested specifically in those, come to this catch-all page. But we're going to move on to things which are designed to be soldered specifically onto PCBs. So I mentioned that the Pico and Pico 2 were pin-for-pin compatible if you wanted to put the actual board down onto a PCB, but there are alternates available as well. There's the Pico SysHigh 2 breakout module by Switch Science, which is castellated and allows you to put it straight onto a development board, and the RP2350 stamp by Solder Party, which we'll take a look at briefly now. So the RP2350 stamp is a PCB version of a development board, essentially. You can drop this right onto your PCB designs, and it means you don't have to worry about any of the external components that the RP2350 requires. This is for the RP2350A variant, the same one found on the Pico 2. They also have an XL version, which is found on the stamp XL, which is the RP2350B variant, which has a lot more pins. All 48 of the GPIO pins are broken out, and both of these boards also come with 16 megabytes of onboard flash and a 500 milliamp 3.3 volt LDO, which is a really good way of powering it, because that means when your input and your output are close to the same level, you're going to get a very noise-free operation. But I don't know enough about it to really go into too much detail. Now, it says there's footprint for a second QSPI flash or PS RAM if you need more of that. And then everything else here is broken out as well. LiPo supply and charging circuit with a charging LED. The USB is broken out, the software debugging is broken out, and there's a reset and a boot select button as well, along with a 12 megahertz crystal for external timing if you require. Now, the original RP2040 stamp came with a development board that attaches to it, which is something that will be available as well. In fact, if you already have the RP2040 stamp variant and the carrier board, the RP2350 will work straight out of the box because they are pin-for-pin compatible with each other. The 2350 and the 2040 2040 variants. However, the XL version, of course, will not fit because it is larger. However, they have a carrier board which will be coming out with it as well, as you can see, with flexi pins, which is very nice. Flexi pins mean that you can attach it to this carrier board without soldering it whatsoever. You can do all of the work you need to on the carrier board before integrating it into your designs. However, as the story continues with most of these boards, these are not available. They are coming soon. The Electrons page for Solder Party has them, and the Tindy account does not list them at all as yet. However, when they are available, I imagine you will buy it on Electrons or Tindy, as it is under the RP2040 version just here. So a very quick whip through of a few extra things. There's a new version of the Bus Pirate. If you're not familiar with the Bus Pirate, it's a very nice box that allows you to make hardware hacking a lot easier. In short, it allows you to do current measurements and logic analyzing of various things, and it even has a single button on it so that once you've set up a test you need to do over and over again, you can just press the button to repeat it, which is such a simple but nice way of doing it. The RP2350B has allowed them to put out a new version called the Bus Pirate 6, which allows it to run as an always running logic analyzer behind the scenes, using the extra pins to basically have a follow-along effect for the logic analyzer, meaning that every single thing that you're doing can be logged using an external tool, which just makes this thing even better. The Bus Pirate is something that I talked about so briefly a long time ago that I think it deserves its own slot on a show, so we'll go into it in the coming weeks at some point, I think. Up next, the Thummy is something I've loved for a long time. The truly tiny little Game Boy version they had, which is actually smaller than my thumb, is something that I backed a long time ago on Kickstarter, and it is a fully functional, tiny little microcontroller-based retro gaming platform with loads of people making games for it. They have come up with a color version of the Thummy, which uses the RP2350, which is, as you can see, a riff on the Game Boy Color, or the Game Boy Advance, as this shape is actually. So if you're familiar with that and you'd like to find out more about it, this is one of the ones that I will link this page in the description. You can just jump straight to the Kickstarter there. And the Thummy Color comes with a number of upgrades, but of course it is a very easy thing to hack your own games into as well. You can program it with MicroPython, you can program it with C, you can do whatever you want with it, or you can just have it as a super cool little thing. And as you just saw on the screen, one of the things they added to it is a vibration motor, which I think is just such a wonderful addition to someone who was very excited when haptic feedback became a thing in computer games. I only wished I owned a console that actually would do it, and when I finally got one, it was very exciting. The Pimoroni Explorer is an explorer's board for anyone who wants to work with microcontrollers and breadboards and things like that. It has a number of wonderful ways of connecting to it, but in short, it has a breadboard, it has a way of connecting servers to it, it has user accessible buttons, it has a variety of ways to connect to it solderlessly, so Stemmer, Qt or Grove via I2C as well, and it has a built-in screen as well. It is available on pre-order. There's a board-only version, which is £33.90, or a starter kit for £60, which includes a few extra bits and pieces as well. I think I'm going to let this one speak for itself.
Almost lost forever and leaving no trace, floating through the darkest reaches of space, just gravitational.
Yes, the Bob and Steve space effect is a Eurorack module giving reverb and granular delay. That sounds wonderful, as you just heard. A project that's been worked on for more than 20 years, but this latest variant of it uses the RP2350, and they've just been porting it over to that. And this is actually from Superbooth 2023, so if anything, it will be more powerful and will actually sound even better than it did before. And if you're interested in this one, it's not available yet. There's a bit of a theme running here, but this will be €440, which if you're in the Eurorack world seems about right. Now, just last week we talked about WizNet teaming up with Raspberry Pi for a combined RP2040 and W5500 Ethernet controller. And I think we can be fairly sure that we will be seeing that soon. However, they're putting out a version first, which is the W550 EVB Pico 2, which combines the RP2350 with their W550 Ethernet controller, not in one chip, just on the same board. This is again coming soon. The theme continues. continues. But if you're looking for an Ethernet version of the RP2350 with a well-trusted and well-used industry-standard Ethernet connector, this is going to be something you'll be interested in looking at. And if you look here, there's actually a list of different things here, which will be coming out quite soon. So this is the RP2350A, which uses the W550 chip. There's another version that uses the W5100 chip, and then a version using the W6100 chip. All different Ethernet ICs from WIZnet. And then, of course, the W55RP20, which they announced on Twitter the other week, which was a single IC variant of it, cutting down on your bill of materials. And of course, this will be working in the future. We can be fairly sure there will be the version that works with the RP2350 as well. But for now, there's still a couple of different versions that will be coming out soon. This is the W55RP20 board. So a development board, which is going to be very similar to the ones that we're looking at here, but with the single chip solution on it too. So when these things actually appear and become things that are available to buy and, you know, something that we can play with, I will probably get my hands on at least one of these, because the idea of having a neatly programmable microcontroller board with all of the bells and whistles of an RP2350 with an Ethernet controller, which presumably can do power over Ethernet, if I can remember correctly, that will be a very useful thing to have in the corner of the room to see if I can get it actually working the way I want to as a nice smart home connected device. Now, there are, of course, going to be many more boards that feature the RP2350, and I didn't even have time to go into a few of the other really interesting ones I saw here. There's the Hellbender development board, which is super long, that breaks out absolutely everything that you could want on it, but is long rather than big. There's also one board, by the way, every time you refresh this page, everything shows up in a different order, which is slightly difficult for someone who's trying to make a YouTube show about it, but that's fine. There was another one that I found very interesting that I do not have time to talk about today, so we'll have to come back to, and that is this, the Neutron Pico by the Neutron project. This is a mini ATX design for a motherboard, essentially, that you can solder a Raspberry Pi Pico onto, and of course, this design will be completely compatible with the Pico 2 because the Pico boards are pin for pin compatible, as I have said many times in this episode. But that is it for the launch of the Raspberry Pi 2350. I am very excited to hear what you think about this new launch. I think this is a really clever thing that Raspberry Pi have done. This chip is going to appeal to pretty much everybody, and with the development board costing just $5, they've kept that price point down very low. It seems like a real win-win. That has been our show for this week. Thank you so much for joining me, and thank you for the continued support that you are showing us here at Electromaker, whether that's by clicking like and subscribe and leaving comments on our YouTube videos or shopping at our online store. Be sure to check out the latest product of the week from Robin Mitchell, along with the Electromaker Educator series that he makes. Those are, the former is a high-level overview of various different products that come in the maker and embedded space, and the latter is an educational series based on various different kinds of hardware. His latest piece about automating a Lego planetarium is just wonderful. It's one of my favorite things that we've ever put out by Electromaker, and I had nothing to do with it. So I would highly recommend checking those out if you haven't already. The next Electromaker show will be coming out actually quite soon after this one, just because of life stuff. I'll be away quite soon, so you'll be seeing my face rather soon, actually. But until then, I hope you have a fun, safe, and creative week, and I'll chat to you soon.